Stop. If you just saw tiny white bugs crawling across your soil, put the pesticide down. That instinct to reach for it? It's about to destroy the one biological system keeping your root zone alive. Every panicked collector sees the same thing. White specks, moving, multiplying. It looks exactly like an outbreak, root aphids, mealybug larvae, a silent infestation eating your $500 aeroid from the roots up. So they spray. Immediately. Aggressively. Case closed. Be honest down in the comments. How many of you have already reached for a spray bottle this month? Because it isn't an infestation. It's a functioning ecosystem, and you're 3 seconds away from wiping it out. By the end of this video, you'll know exactly what's living in your substrate, why it's the reason your albo isn't rotting, and the precise diagnostic method that separates a real threat from a beneficial colony. No guessing. No spraying blind. Here's the hidden mechanism most collectors never learn. Those white insects are collembola, soil springtails, and they are not attacking your plant's vascular tissue. They physically cannot. Springtails have no interest in living plant matter. Their entire biology is built around one function: decomposition. Think of them as an underground cleanup crew, a maintenance team working the night shift in your root zone, 24/7, for free. What are they actually consuming? Decaying organic matter, dead root cells that naturally slough off as your albo grows. And this is the part that changes everything. Microscopic spores of Pythium, the exact fungal pathogen responsible for the root rot that kills more premium aeroids than every other cause combined. But it gets worse for the spray-first crowd, because springtails don't just eat the threat. They physically restructure your substrate while they do it. As they tunnel through your mix, they carve microscopic pathways through compacted soil particles. Every tunnel is a microchannel for gas exchange. Picture your root zone as a city. Oxygen is the traffic trying to reach every neighborhood. Compacted substrate is gridlock. Springtail tunnels are the underground metro system quietly keeping everything moving. This matters because roots don't just drink water. They breathe. Root cells respire. They consume oxygen and release carbon dioxide, exactly like your lungs. When a substrate compacts and that gas exchange stops, you get root hypoxia, which is really just a scientific way of saying your roots are suffocating. Hypoxic roots don't just weaken. They send out a distress signal, a biological panic button, that shifts the plant's internal chemistry towards stress hormones instead of growth hormones. And a stressed, oxygen-starved root system is precisely the environment Pythium thrives in. It doesn't need to attack a healthy plant. It waits for a suffocating one. So here's the aha moment. Springtails aren't a symptom of a problem. They're a sign your substrate still has a functioning microbiome capable of defending itself. A soil with zero springtail activity isn't cleaner. It's often biologically dead, sterile, compacted, and one overwatering event away from a fungal takeover with nothing left to stop it. This is symbiotic arthropod bioaeration, which is just a fancy scientific way of saying bugs digging tiny air vents so your roots don't suffocate. It's not pest activity. It's active root zone insurance, which raises an uncomfortable question for anyone reaching for a spray bottle right now. What exactly do you think happens to that insurance policy the moment a systemic pesticide hits the soil? Here's where most collectors completely ruin their investment. A broad-spectrum insecticide doesn't discriminate. It doesn't know the difference between a root aphid and a springtail. It annihilates every arthropod in that substrate within 48 to 72 hours. The visible bugs disappear. The collector feels relief. Problem solved, or so it looks. But the cleanup crew is gone. The tunnels stop forming. The decomposing organic matter that was being processed now just sits there, undigested, compacting. This is the negative economic loop nobody talks about. Within 2 to 3 weeks, the substrate's porosity collapses. Oxygen exchange drops. Root hypoxia sets in, the exact condition that invites Pythium in the first place. Except now there's no biological checkpoint left to slow it down. The collector sees yellowing leaves a month later, mushy stems, black root tips, and they don't connect it back to the spray, because the timeline feels disconnected. It isn't. It's cause and effect on a biological delay. Then comes phase 2 of the standard mistake: systemic chemical fungicides. poured directly into the soil to fix the rot that the pesticide indirectly caused. These synthetic treatments don't rebuild the microbiome. They mask the collapse. They suppress visible fungal growth on the surface while doing nothing to restore aeration, nothing to restore the decomposer population, nothing to address hypoxia. It's the botanical equivalent of treating a structural crack with paint. Big box store advice makes this worse. White bugs in soil? Spray immediately. Generic, one-size-fits-all, written for petunias, not for a philodendron spiritus sancti that took you 8 months to source. Standard advice treats every soil organism as guilty until proven innocent. Premium growers can't afford that assumption. Not at this price point. Not with these species. The real cost isn't the $12 you spent on pesticide. It's the collapsed substrate, the 6 months of recovery, or the total loss of a plant that was never actually sick to begin with. So if spraying is off the table, what's the actual protocol? Here's your exact diagnostic and action sequence. But fair warning, if you skip part 1 and jump straight to part 3, you will accidentally trigger the exact root rot we are trying to prevent. Every part of this protocol depends on the one before it. Let's start at the beginning. First, hit them with the chopstick test. Springtails bounce away like tiny acrobats. Pests just sit there, clustered on root tissue, feeding. Next, verify your moisture. Insert a moisture meter after watering. If your pot stays wet past day 5, your soil is already suffocating. That's your compaction warning, not a bug problem. Don't kill them, feed them. Top dress with about 1 inch of worm castings to give your cleanup crew fuel. If your substrate is old and compacted, swap it for a porous, pumice-heavy aeroid mix. A structurally open blend keeps oxygen flowing and gives springtails more surface area to tunnel through effectively. And if fungal rot has already set in, dark, mushy roots, a sour smell at the base, bypass the harsh chemicals. Use a targeted organic biofungicide containing Bacillus subtilis. It kills the bad fungus while keeping your bug partners safe. If their numbers explode and it skews the aesthetic of your display plants, don't panic. A light dusting of diatomaceous earth, only on the topmost dry layer, thins the surface crowd without hurting the underground workers. And this part matters. It has to be bone dry. The second diatomaceous earth gets wet, it muds up and becomes completely useless. No barrier effect, no population control, just a wasted step. Once your substrate has proper porosity, a stable moisture curve, and a light organic top dressing, the colony becomes self-regulating. Congratulations, you've built a self-sustaining ecosystem. This is the difference between amateur reactive care and the way serious collectors actually protect a 5-figure collection. Read the biology first, intervene surgically, and never nuke a system you don't fully understand. Your soil isn't infested. It's alive. Like someone who actually understands the biology underneath the plant, not just the plant itself. And if you think your root zone looks clean right now, you need to see what's actually happening under the surface of a compacted pot, because the next video breaks down the exact silent signal your roots send out before rot ever becomes visible.